everyone, welcome back to our channel. Today we are going to solve problem number 36. So this problem number 35 is all about find the current in the branch IL given as 1 ohm using superposition theorem. Okay, so now how many sources are there? So this is source 1, this is source 2, this is source 3. So let us try to mark three different currents. I am marking these currents as total current IL is equal to I1, I2, I3. I will mark the polarities based on the flow of currents. Okay, so now we need to find out this. In order to do it, so first I am going to activate 2 volt source. Okay, I mean 2 volt source is activated, remaining 5 amperes and another 5 ampere sources are deactivated. The meaning of deactivation is this will act like an open circuit. Now you can see here this source I am activating and I am redrawing the circuit. Okay, so 2 volts is active now. The remaining circuit, this source is deactivated and this above source is also deactivated. Okay, and here we require the current. This is nothing but 1 ohm. We require the current I dash, sorry, I1. So and at the top you have a 1 ohm resistor. Okay, so this is nothing but a 1 ohm resistor. This is another 1 ohm resistor. This is 1 ohm resistor, and we are exciting with a voltage of 2 volts. So if you have any confusion, mark this as node 1, mark this as 0 0 0. Okay, so now between here, this is the current starts flowing in the 1, the current starts flowing in the 1, and the same current also will flow. I can say now these two are connected in series connection. Okay, and these two are again in parallel. So 1 plus 1 is how much? 2 ohm. And at the top we are going to have one more branch is nothing but 2 ohm, and this is excited with an voltage of 2 volts. And here we have that current where this is nothing but I1 and this is of 1 ohm. Again you can see here the current flows and current is dividing. I can say now these two branches are again connected in parallel. Okay, so whenever they are connected in parallel, so I'm going to get a single resistor like this and a branch like this. Okay, so these two are connected in parallel. The formula is product of resistance divided by sum of resistance, where this is nothing but 1 ohm, and the current here I require is I1. Okay, so this is excited with a voltage of 2 volts. Therefore I1 is equal to, okay, current is leaving. What is the leaving polarity of the voltage? Current I equal to V by R, that is equal to, so current is flowing, the voltage is 2 minus 0 divided by R. R is how much? 1 plus 1. So 1 plus 1, that is equal to, we are going to get a total current of 2 by 2, which is nothing but 1 ampere current. So successfully we find the current I1. So now the second step we are going to solve. Second step, here I am going to activate the second source, which is nothing but this source I am activating. Okay, second one, 5 ampere source is activated, and you can see here automatically 2 volt source as well as third source are deactivated. I am redrawing the circuit. You can see carefully here. So this 2 volts is short circuited, and here I have 1 ohm, and here I have a 5 ampere source, and this is connected like this, and one more source. This above source is also deactivated, that's why it is open circuited. And this branch we require, we are labeling the current in this branch as I2, and here we have the another branch. This is the another branch. The value of this resistor is 2 ohm, This is 1 ohm. This source is short circuited. This source is open circuited. We need to find out the current in this branch, which is nothing but L is equal to 1 ohm. So how to find out? Okay. So you can see here, in order to overcome the confusion, this is node 0, this is node 0, and this is also node 0. And since it is short circuited, here it is connected. Okay. So now let's try to mark this as node 1, this as 0. Okay. So now I'm redrawing for our clarity. So same 1 ohm, and the current source is in this direction, which is 5 ampere, and this also will be there, and here it is connected. So here in this branch we require the current. The current we are labeling it as I2. Now between 1 and 0, okay, this branch is connected. Okay, so between 1 and 0, this branch is completed. So here I have 1 and here I have 0. Okay, so between this 1 and 0, what is connected? This 2 amperes is connected. Sorry, 2 ohms is connected. I'm redrawing that separately to give them clarity. This is a 2 ohm connected between 1 and 0. Okay, so this is node 1 and 0. So the value of this resistor is 1 ohm. The value of this branch is 1 ohm. Okay, so now we are going to get two different nodes. So this node, we are considering it as some AVX node, and the resistor is there. This will act as an another node. Let's try to label it as some VY. So now let's try to find the currents. So our target is to find out I2. Okay. So now let's try to mark these currents as some I1, the current which is flowing in this branch, and already one current is leaving, and this is another current flowing in this direction. Let's try to mark these currents as some I3. Okay. So now similarly to this node, so I1, I2, I3 is completed. This current I am going to mark as I4. This current I am going to mark as I5. Now see here, so to solve this problem, we need to find out, actually we need to find out I2. Okay, so I2 is equal to how much? V y minus 0. Okay, so how to write down I2? V y minus 0 divided by the value of this resistor is 1 ohm. It's nothing but 1 ohm. Okay, now let us try to observe. Okay, so in order to find this Vx, I am applying nodal analysis. Apply nodal analysis is indirectly applying Kirchhoff's current law at node Vx. Okay, here you can see here how many entering currents are there, how many leaving currents are there. Here you can see here all are leaving currents. Therefore, 0 is equal to I1 plus 5 plus I3. So therefore 0 is equal to, how to write down I1, how to write down this branch current exclusively. So current is leaving plus Vx. So Vx minus 0. So I would I1 Vx minus 0 divided by 1 plus 5 plus, how to write down the current I3 which is flowing in this direction, Vx minus Vy by 1. Okay, so how to write down I3 is Vx minus, okay, so somewhere it is leaving, therefore I Vx minus Vy divided by, what is this value? 1. So when you convert into an, do all this calculation and express in the form, so 2Vx minus Vy is equal to minus 5 is the first equation. Okay, so second equation here is, here you can see here actually, if you take I2 like this. Okay, let's try to apply one more nodal analysis. Apply nodal analysis is indirectly KCL at which node? So at this node you apply the nodal analysis at the node Vy. You can see here, to this node what are the entering currents? No entering currents, all are leaving currents. Okay, so I'm going to write down this as I2 plus I4 plus I5. So actually, this is the source. You should take like this. Okay. So therefore, when you take it like this, so okay, no issue. Let we will write down. So zero, no entering current. We are taking it as I2, but the original current is minus I2. It goes in opposite direction. Okay. So zero is equal to. So no need to write down, we have to find I2. So how to write down I2? I2 is the current flowing in this branch. How to write down is Vy minus 0 divided by 1 ohm. So how to write down this current I4? How to write down the current I4? Which is nothing but Vy minus Vx divided by 1 plus how to write down the current I5. So this we can write down it as V y. How to write down the current I5 is Vy minus 0 divided by 2. So when you solve it, express all, this is nothing but 0 is equal to Vy plus Vy minus Vx plus Vy by 2. Separate Vx and Vy terms. Therefore, you are going to get minus Vx plus Vy as a common term. So when you take Vy as a common term, 1 plus 1 plus 1 by 2, that is equal to minus Vx plus Vy of 2.5. So this is equation 2. So solve with your calculator first equation and second equation, then we are going to get the values of Vx is equal to minus 3.125 volts, Vy is equal to minus 1.25 volts. But actually what we require is the I2 value. So I2 is equal to, what is Vx Vy value, minus 1.25 minus 0 divided by 1, so which is nothing but minus 1.25 amperes of current. Okay, so this is the current which is flowing in this direction. Okay, so now successfully we find the second current. Next we need to find out the third current. Okay, so let's try to find the third current. I'm copying the circuit diagram. So now we are going to activate this source. Okay, so now we are going to find out I3. Okay, so this source is activated, this is deactivated, as well as this is deactivated. Okay, so now I'm redrawing the network. So this source is short circuited. Okay, and we are going to have a 1 ohm resistor, and this source is also volt current source is open circuited, and here you are going to have a 1 ohm resistor, and here you are going to have an current source with a current of 5 amperes like this. Okay, and in this branch we require the current. So let's try to mark this current as some I3, and there is a one more resistor connected between these 2 points. Okay, so for reference I'm taking this is 0, this is 0, automatically this is 0 since it is short circuited, this is 0, and let's try to mark this as a one more node, some as VZ node. Okay, so this is 2 ohm. So now what we can do here is, this is creating some confusion, so let's try to apply source transformation technique. Okay, so by applying source transformation technique, so here I have 1 ohm, and once again this is open circuited, and this is short circuited, and here I'm going to get one voltage source. This is same resistor R Thevenin, and current is flowing in this direction. Automatically, this will be positive polarity, and this will be a negative polarity, and we are going to get a VZ node, and here is our load resistor available, where this is nothing but RL, and we need to find out the current I3. And you see here, between the Z, VZ and 0, one more branch is connected, there's nothing but 2. Okay, so here one more branch is connected, this is 0, 0, 0, 0. Okay, so there is one more branch connected, 2 ohm resistor. Okay, what I require is I3. So I3 is equal to VZ minus 0 divided by 1, where RL value is how much? 1 ohm. Okay, so when you do it, so let's try to mark this current as some uh, Ix, this current as some Iy. Okay, so now we are going to apply, okay, to find the value of Vz, apply nodal analysis is indirectly KCL at node Vz. Okay, so this is 1 ohm and this is also 1 ohm. Okay, so what are the entering currents? No entering currents, all are leaving currents. There's nothing but Ix, okay, plus Iy plus I3. Okay, so 0 is equal to, how to write down this total current? Okay, so here this is a voltage source, V is equal to I into R. I is how much? 5 into 1, which is nothing but 5 volts. Okay, so now how to write down the current in this branch? So current is leaving, this is nothing but, so the current is leaving in this direction. Okay, so when you're writing this is nothing but minus 5 minus 0 divided by 2, plus how to write down the current Iy, Vz, so how to write down Iy, Vz minus 0 divided by 2. How to write down the current I3 in this branch? Vz minus 0 by 1. So this is starting with the Vz. Okay, so Vz minus 5 minus 0. Okay, so now we are going to simplify it, and we are going to get the value of Vz is equal to, okay, when you solve it, you are going to get it as some 1.25 volts. Okay, but what we require is Vz is 1.25 by 1. Okay, so now successfully we had got the currents. Okay, 1.25, and next one is also minus 1.25. So you can see here, here in this branch the current is flowing from top to bottom, so this is nothing but plus I1. So in this branch actually the current is flowing in this direction. Okay, so current is, the source is from this direction, it is flowing in this direction, by we assumed in top to bottom, so that's why to our obtained current, and this current is in opposite direction, therefore we are going to get it as minus. Okay, next one. So the third current is also flowing from top to bottom. So we should substitute plus. So just substitute the values of I1. So I1 is 1 volt minus 1.25 plus I3. So what is the value of I3 we obtained? I3 is 1.25. Okay. So when you do it, you see here, so here we have to write down minus I2 current. Minus into minus is nothing but how much? So this is, current is how much? Minus 1.2. But the original current is in this direction. Okay. So therefore you are going to get cancelled out, and you are going to get it as some 1 volt. So this is the process of solving the problem. Okay. So hope you are able to understand the problem. Okay. So this is how we have three multiple sources. Okay, so here sometimes you may get confused. So how to take the currents? Okay, so very simple. So three currents are there. First current is flowing from top to bottom. That's why I had kept plus. Okay, but this current has to flow in this direction. Okay, so in this direction it has to flow. Then only this is positive. So this you can write down it as plus. Okay, in this direction if it is flowing. Okay, and I3 is also flowing in the same direction. That's why this is also plus. But our assumed direction is how much? From top to bottom. If it flows in this direction, so what is that value? Is nothing but same you are going to get. Then we are going to get this value as a 1 volt. Hope you understand the problem. If you feel the problem is clear, please like the video and share with your friends. And if you are watching the channel for the first time, subscribe the channel with the name KB Tulasiram, and kindly encourage these type of free channels for the development of students as well as for the faculty. Hope we'll meet in the next video. So some students may get confused what happens here. Okay, just go through the problem, then you'll get a clarity. Thank you for watching.